we're going to start by just kind of going over the areas that we're covering. So first, we're going into cost-effective Azure pricing options. What this is going to be is a breakdown between reserved instances, saving plans, spot instances, and hybrid benefits. I'm just going to be using one of our subscriptions for this. For demo purposes, I've left a couple of resources underutilized on purpose. So we have a couple action items here. So as it relates to Azure cost, many of you are more than likely very familiar with the cost management area within Azure. That kind of breaks down your existing costs as it relates to each individual services. However, you may not have a good idea of what to kind of do past that, or that there are things you can do past that to kind of reduce your cost. So first and foremost, we're talking about reserved instances. All reserved instances is basically a promise to Microsoft saying that you will use a certain size of virtual machine, for example, or app service for 1 to 3 years. And this can generally reduce your cost down up to about 70 to 80%. Now, the main snag here is that reserved instances can only be applied to a single resource. So when looking at, for example, you have 3 virtual machines that are relatively expensive, but you know you're going to be using those in the next year or 3 years, and you don't need to change the sizes very often, reserved instances would be a very advantageous purchase for you to make, as that would likely reduce your cost down a significant amount. Here shortly, we're going to go into the actual advisor. Once I kind of get through the different types, the advisor will actually kind of point you in the right direction, or at least show you the very high level action items you can knock out as it relates to cost management. And then we'll kind of go into the deeper areas of actually doing it by hand. So this is the area to purchase reservations. You can kind of see here, these are all the workloads that are currently supported. It's very important to remember reserved instances are on a per resource level, meaning that if, for example, you wanted to get some reserved instances for your virtual machines, let's give it 1 second here. It's going to calculate everybody. Let's switch this to actual production line. So this will list the virtual machines, for example, that we have within the subscription, where they currently are region-wise, what size they currently are, and how many they would recommend you purchase. For example, our standard B2s here, we have 2. That would likely reduce the cost on those about 70%. When thinking of cost within Azure, especially as it relates to virtual machines, keep in mind that there are 3 elements that determine your pricing. Sometimes there's 4. There's storage, there's the actual compute, and then there's the actual renting of the operating system license itself. Reserved instances are meant to cover the compute piece of that. Now, having said that, if you do have managed disks, you can also reserve instances on those. Also, if you're seeing your costs are blowing up in your Azure storage and you know you need to maintain those storage accounts for 1 to 3 years, I would highly suggest you implement reserved instances to reduce your costs. Now, let's go to a different use case, and that you don't necessarily know you'll be using these virtual machines at this size over the next year or 3. Or you don't know how many different machines or app services you may need to reduce your cost on because you're still building out your solutions. That's where savings plans would be a much more effective approach. So the main difference between saving plans and reserved instances are that saving plans are not scoped to a single resource. They can actually be scoped to the entire subscription, or to an individual resource group, or to a management group that you've already created. The other main difference is that savings plans apply to all the resources compute-wise that you cover. So it would be app services, your virtual machines, and you are not locked to any specific size around those services. It's really just a commitment saying we're going to be using this amount per hour within Azure, and Microsoft will discount. Anything that goes past what you have committed to in terms of compute will just be billed at regular pay-as-you-go rates. So saving plans aren't as dollar for dollar effective as reserved instances. However, they can be applied in a sweeping fashion where services are added, other resources are added, removed, sizes go up and down. It's basically much, much more dynamic. So if you're going to be changing your infrastructure a lot, or if you're not entirely sure if you're going to be using the infrastructure you currently have and you're still adding pieces, removing pieces, saving plans are really where you're going to want to go. Since the reserved instances, you would have to either refund or cancel reserved instances for that size and purchase another one, especially if you're jumping regions or anything like that. The only negatives really to saving plans is these cannot be canceled. Reserve instances can be canceled and refunded and prorated up to a certain amount. I believe it's about $50,000 in a single year. You can cancel reserve instances, but saving plans you cannot. The other really neat way to reduce your costs is with spot instances. So a spot instance is a virtual machine that is labeled as a spot instance. But what that actually means is that you're basically allowing Microsoft to pick your machine offline should they need additional resources. Spot instances are very, very useful for asymmetrical work. Basically meaning if you have a machine that comes online, processes a lot of information or does a job, submits it, and then it's pretty much be shut back down. Spot instances would be great because you can reduce your costs by about 90% across the board, so long as you're okay with the idea that at certain times your machine may stop randomly. So it's really going to be dependent on what kind of solutions you build, if that will suffice for you. Other common uses of it are Databricks clustering or any type of machine learning modeling. You can fire up an obscene amount of instances as spot instances, and even if you lose a couple of the nodes, you're still astronomically better off cost-wise than if you would just do them all straight. All right, and I'll touch on this briefly. Hybrid benefits is something that I find many people are getting confused about within Azure, because on each one of these machines, when creating a virtual machine, it does ask you if you'd like to enable hybrid benefits. Hybrid benefits basically just tells Azure not to bill you for the operating system, because going back to what I mentioned, that on every single virtual machine, you're actually paying for the compute of it, but you're also renting the license. So if it's running Windows, for example, you actually have a charge for renting that operating system. All the hybrid benefit does is say, we already have a legit license for Windows, for example, don't bill me for that. Now, when you're actually in compliance of using hybrid benefits, is only really in two scenarios. You either have that operating system under a software assurance agreement, or you have a subscription to it. Not many people are familiar with operating system subscriptions, but as a CSP, we are able to issue subscriptions to, say, for example, Windows Server. Operates very similar to like your SAs in the past, where it's just pretty much a license for the latest version going forward. But the other main benefit is that it also works as a hybrid use license. And if you really want to fry your brain a little bit, it's actually cheaper to purchase the operating system subscription license than to leave your machines non-hybrid. Or I should say not using the hybrid use benefit, because there is a surcharge for renting the operating system, and it is more expensive than a subscription. All right, so kind of went over when to use each of those four. Reserved instances being when you know your existing load and on what service and what size. You know you're going to be on that for about a year or three. Reserved instances can be upgraded and they can be canceled. Then we have our savings plans. These are for much more dynamic build outs where you're just committing to the amount of compute that you will use and you'll get a discount for that. And then anything past that is just billed regularly. And then spot instances. That's just when creating the machine, you label it as you can evict this should you run out of capacity. And that reduces your cost by about 90%. But again, spot instances should really only be used for asymmetrical workloads. If you're unsure if your workload will qualify under that descriptor, I would say that it's more than likely not asymmetrical. So next, we're going to kind of go into, well, this is all nice and good, but how do I kind of save myself all the trouble of digging through all of this and figuring all this out? So Microsoft, with their cost management, has actually gotten pretty good at this. So your cost management is showing you your costs as it relates to each service, but it's actually not the place that you're going to want to go. Next, we're actually going to want to go to advisors. So advisor, really, really good at kind of figuring all this out, at least on the high level items of where you should go. So for example, here under just the advisor, under cost recommendations, looking at some of our subs, and we can already see that we have reserved instances need to be done for these machines. We have saving plans that can potentially reduce the cost for this subscription, and then also we have underutilized virtual machines. If you are not checking the cost advisor area within your Azure instance periodically, I would highly suggest doing so. As you kind of see here, high-level items like this that just aren't attached to anything will be labeled here. Any machines that don't have reserved instances that it should be, and any machines that are way over the top in terms of what they're currently sized to. So, for example, the CPU utilization of this machine, it sees it 13%. It suggests we roll that down to a D2 instead of DS3, and then put that on a reserve instance, and you would dramatically reduce the cost by about 80%. If you need to figure out kind of how much this would save, let's say, for example, you do not have the output within this advisor, I would highly suggest also becoming familiar with the Azure pricing calculator. This pretty much allows you to create your theoretical scenario, and if you are going to, for example, reserve it, or if you're going to use a savings plan, you pretty much kind of go through here and see what that would kind of cost based on your current setup. So as you can kind of see, here's where we're describing the Azure hybrid benefit. So if you had a subscription to Windows, or if you were under software assurance, you could use that. You kind of see how significant that operating system license is. Most people, for whatever reason, do not realize that. But it is a good chunk of your spend. If you combine the higher benefits and the reserve instances, you get to a shockingly tiny monthly spend. So you can kind of see with just a regular D2 on a pay-as-you-go regular license, $137, but when you actually knock that down to higher benefits and on a reserve instance, you're looking at $26. So as you can kind of see, the dramatic savings that could be here. But again, this being a reserve instance, you would not be able to change this size. You would be able to upgrade it, but you can't downgrade, and you would be able to cancel it. And you kind of see his saving plans aren't as dramatic, but again, that's because they can be applied to all other resources related to compute and not necessarily just this one. This is a great tool to kind of run through, especially if you just want to get a ballpark on how much you could save. If it's not showing up in Advisor, they try to do some of the legwork for you, but there's a lot of little things in here that will annoy you. For example, the virtual machine names, for whatever reason, they don't drag them in here, and you have to line up the sizes yourself. We're actually working on something to handle that for you, but that pretty much runs through the different types of resources, reservations, saving plans, and the high level kind of cost savings. So now let's kind of get into hunting down unused resources. Everyone knows, or anyone who's been in Azure for a while now, or any of the cloud technologies knows, you have to be somewhat mindful of sprawl as it relates to your Azure instances. It's way too easy to spin up services, potentially solve a problem, and either forget about them or leave them down. And leave them running and just basically costing you for nothing. So there's quite a few different ways we can actually hunt this stuff down. As I mentioned, the advisor will tell you things that are just blatantly obvious, such as disks that aren't attached to VMs. However, it's not going to tell you resources that aren't used because it has no real understanding of, is this a project in what's coming up? Is it old, et cetera? So how do you go about identifying dead resources? I would highly, highly suggest you get somewhat comfortable with the monitor area within Azure. What this allows you to do is to break down those individual resources and actually see their actual usage telemetry. So for example, I'm going to just use this as an example. If I were to want to clean up dead storage accounts, I could go to storage accounts, the subscription, the types, and get the time range. And I can see kind of here which ones are very, very obvious in production and which ones are not. So for example, this one is not used at all versus the 4.7 million operations that's currently going against my other storage container. This is extremely beneficial in hunting down dead services as well as potential right sizes. Now, we'll kind of get into that a little later, but kind of get the idea of how you were able to use this to determine the availability and the usability of your machine. So that'll help you hunt down any unused SQL databases too. Also a good example, you can pull the actual database performance on them. We'll kind of get into that once we go into the right sizing. And I don't think I have any containers. So yeah. So the other areas that the advisor will also help you find is if you have any unassigned IP addresses, unassigned disks that I've mentioned, basically anything that's not attached to any others. Past that, I'd highly suggest using this to kind of see if you have any storage containers that could be removed. SQL servers, we'll kind of go into very shortly, but this actually is a very easy way to get a sweeping view as to what's used and what's not within your Azure instance, especially for like screen testing, because you're able to turn off services and make sure they work. Next, we're going to get into tagging and why tagging is so important. So as we're kind of talking about how there's different resources, the different regions, the different savings, and providing kind of overarching visibility. I cannot stress enough, tagging is extremely important if you have any need in terms of granular control, in terms of granular visibility for cost, in terms of managing the resources. Tag is where you're going to want to be. So we're going to start with just one of the simplest benefits to tagging, and that is your kind of cost management that will allow you to break that down by tag. So for example, let's go to, let's get our resources up. And what we'll do is, actually, let's do accumulated. That'd be better. Add our filter here, and we're going to only do ones that are tagged and that are, for example, in production. And actually, let's get all of those. Optimization's not in there yet. All right. So as we kind of see here, you're able to use those tags to generate your own kind of pre-sliced data from cost visualization. Tags are super important because you're able to pivot off of them for obviously cost visibility, where you're assigning certain tags, such as what workloads it's related to, what customers it's related to, what departments it's related to, and then pivoting off of those for cost. But it goes even further than that. You can actually do RBAC permissions based on these tags. So for example, if you have a distributed IT team, let's say your Seattle IT department, and they need permissions to different areas within Azure, instead of having to kind of create a structured managed group kind of landing zone whole setup, you could implement RBAC based on tagging, and anything that's tagged in a certain way, they would have permissions too. That could be extremely beneficial instead of maintaining all your different individual RBACs. However, it can get a little much and heavy-handed if you go too crazy with tagging. So I say all that with these kind of caveats. The most important things when you're dealing with tagging are that you are consistent with your nomenclature in terms of how you're labeling everything, that you plan ahead, and that planning ahead is absolutely critical, especially if you have a rough idea of what you're going to want to use the tags for. Again, they can be used for permissions, can be used for cost visualization. And then lastly, if you have the capabilities, use automation to deploy those tags. While it is possible to do a kind of sweeping tag apply through the portal, and you can also use governance policies to automatically assign those, it's always beneficial to have a little bit of scripting in there to need be, to make sure you get everything labeled. It will make it much, much easier down the road. Next one's gonna be right sizing resources. Okay, so as you may or may not know, within Azure, every resource has a size. For example, this is one of our SBCs that we use. You can kind of see here that we're on an F4, right? So one of the beautiful things about Azure, you're able to step up and down relatively easy. Just obviously know that there is a slight outage when doing so, but the reason that's important is because when looking at these individual machines, it can get kind of time consuming to look through here and decide, is this over allocated? Can I step it down? Can I step it up? So there's much cleaner ways to kind of do that. So we had mentioned Advisor is always a good place to start, because again, it's going to show you your high level items before you even have to dive into the individual ones, such as right size virtual machines. For a manager needs to be right sized. Now, granted, this is a huge jump, but you can go further than this. We're going to go back to our monitor. This time we're going to go to virtual machines, and we're going to grab the performance of all the machines, let's say within the last 7 days. Now, the reason that we would want to do this is because since each one of these machines has its independent price, its independent size, we're looking for ones that aren't really utilizing themselves that much. So for example, we have here our Cloud SBC2 only using 7.28%. More than likely, that can be safely turned down. Now, I say more than likely because, and I cannot stress this enough, be mindful of what workload is on that. Should it go down? Because potentially you may not be seeing a large load on it because it's a project that's in flight. Services haven't spun on it yet. It acts as a high availability failover in that circumstance. So you want to be obviously very mindful of that, because while this may look like a good idea to knock down a couple of notches, since that's a high availability failover, you would not find out that's a problem until a failover actually occurred. So be somewhat mindful of that. But if you have machines, for example, one of our AVD accounting hosts is only at 10% usage on 95th percentile, that can get knocked down in size. probably significantly. This kind of logic can also be applied even on the SQL side and even on the Cosmos DB side. Again, just kind of looking at what your sizing is. So let me actually do a SQL one, so that'd be a good one. We're going to go here to our SQL servers. Now, we're currently running 4 databases and actually left these lopsided for this demo. Each SQL server that you're currently running can each control have multiple databases running on the SQL server itself. Each one of those databases can be allocated a certain amount of power, DTUs, vCores. Side note, generally, DTUs are about to go until you pass about roughly 100, then it's about time to switch to vCores. But 100 DTUs is roughly equal to 1 vCore. You're able to go into each one of these databases and determine if it's the right proper size. So for example, in this automation database here, we can kind of see in the last 7 days, we're fluctuating about 40 to 60% and hitting it every once in a while. So that one may be able to actually get knocked down versus if you see on the reporting one, when I flip that to 7 days, we're hitting our 100% DTU limit repeatedly, more than likely every time we do our massive ingestions. So this would be a good example of one you would not want to turn down because you're already at the limit multiple times throughout the day. Now, when you compare that, though, against the automation database of ours, you can kind of see here that since it is so much more, well, really about 45% or so, 50% throughout most of the workloads, this is a good example of one that can be kind of turned down. The advisor will not go to this level. This is way too much open to interpretation. So I wanted to kind of stress that as to how you can use Monitor to kind of identify these resources to be turned down. Same concept with app services, same concept with, well, pretty much anything and everything that you're using.